Welcome to our tutorial on optimizing React performance using the DevTools profiler. First, we'll introduce you to the powerful React DevTools profiler and how it can help you identify bottlenecks in your application. Next, we'll walk through setting up and navigating the profiler so you can start profiling your components right away. We'll then dive into understanding render traces and component hierarchy. These are key insights that will guide our optimization efforts. Moving on, we'll explore techniques like suspense and lazy loading to improve rendering performance. Finally, I'll share some best practices for keeping your React apps running smoothly and efficiently. Let's get started. Welcome to our tutorial on the React DevTools profiler. This powerful tool integrates seamlessly with Chrome DevTools, offering real-time insights into your React application's performance. It's like having a superpower to spot and fix those pesky slowdowns. The profiler gives you detailed information about component render times, re-renders, and even suspense behavior. Think of it as the magic wand that helps you cast spells on those tricky performance issues. Want to dive deeper? The tool also comes with other tabs like Performance, Memory, and Network for a comprehensive analysis. And guess what? It's available not just in Chrome but also in Firefox. So grab your coding hat and let's optimize some React apps together. Alright, let's dive into setting up the profiler for performance optimization in React. First thing you need to do is install the React DevTools extension on your browser. Chrome or Firefox works great. Once installed, head into your settings and enable it. Now, open your app in a web browser and navigate to the Developer Tools panel. From there, click on the Performance tab. This will allow you to see detailed performance metrics as your app runs. Think of it like having a stopwatch for your React components. Identifying which parts are taking the longest to render can help us pinpoint bottlenecks and optimize our code more effectively. Welcome back. Today, we're diving into understanding render traces, a powerful tool for optimizing your React applications. Render traces give you a high-level view of how components render and re-render within the entire app or just individual parts. Think of it like seeing every step of an animation in slow motion. Each component is color-coded based on its render time, making it easy to spot those deeply nested components that might be causing performance issues. Imagine having a complex menu. If one item is taking longer than others, you can pinpoint and optimize just that section. To capture this action during user interaction, simply hit Record. This way, you get real-time insights into what's happening under the hood. Let's make our app run smoother together. Welcome to optimizing component rendering in React. First up, let's talk about minimizing unnecessary re-renders. Use the shouldComponentUpdate lifecycle method or React.memo as a higher-order component. Next, avoid heavy computations in your render methods. Instead, move those calculations to component didMount or useEffect hooks for better performance. Remember, keys help React identify which items have changed, are added, or removed. For dynamic content, lazy loading components and using suspense can make data fetching smoother. Lastly, where possible, opt for server-side rendering (SSR) to enhance load times. These strategies will ensure your app runs smoothly and efficiently. Hey there, everyone. In this tutorial, we're diving into an essential technique to boost your React app's performance using. This is crucial when you have a component that doesn't need to re-render every time its parent does. Let's take a look at our code snippet here. We import and then define as a functional component. Notice how we pass the data prop directly to the component function. That's because wraps around it, preventing unnecessary re-renders based on props equality. In a real-world scenario, imagine you have a list of items. Using ensures that only the item that changes gets updated, saving valuable processing time. So, by strategically applying, you can significantly enhance your app's performance without complicating things too much. Happy coding! Welcome back, everyone. Today we're diving into two key concepts for improving the user experience in your React applications: suspense and lazy loading. Suspense allows you to gracefully handle asynchronous content loading by rendering a fallback UI while data is being fetched. Think of it like loading a movie trailer before the main feature starts. It keeps users engaged without showing nothing at all. Then there's lazy loading, which helps manage large components or modules by importing them only when needed, kind of like downloading only the parts of an app you're currently using. To implement these in your React code, use the function for lazy loading and suspense boundaries to wrap your components that might need to fetch data dynamically. This way, non-critical content won't block the page from rendering, keeping your app snappy and responsive. Alright, let's dive into using for dynamic imports in React. This technique is super useful for optimizing your app's performance by only loading components when they're needed. Here's how it works. First, we import both and from React. Then, inside our app component, we use to wrap the dynamic import of /myComponent. This tells React that we'll load this component on demand. We also add a component as a fallback UI, which displays while the component is being loaded, like a simple loading message here. Once the component loads, it replaces the fallback. So, by using dynamic imports you can keep your initial load time low and enhance user experience. That's all for this slide. Let's move on to the next one. Alright, let's wrap up today's lesson on React performance optimization using the profiler. First off, remember to use the React DevTools profiler to spot and address those pesky performance bottlenecks. Next, get familiar with your component hierarchy and render traces. It'll give you clearer insights into what's happening under the hood. Then, when you can implement should component update or use react.memo to avoid unnecessary re-renders. Lazy loading and suspense are great for handling asynchronous content efficiently. Also, try to keep heavy computations out of your render methods. Your app will thank you for it. And finally, where possible, consider server-side rendering (SSR) to give your site a nice speed boost. Happy coding!